right, in the next 2 lesson videos, we're going to be covering lesson 10-2, all about measuring angles and arcs, continuing our chapter on circles. So we're going to start right off with some vocab here. What is a central angle? Let me zoom in a little bit. What is a central angle? A central angle is an angle, it says it twice, whose vertex is at the center of a circle. So draw an example. I'm not gonna be able to draw a real great circle. And if we put our center of our circle here, and then we draw an angle like boom, boom, this is our central angle. This guy right here. Right? Any angles measured off of the circle, off the center of the circle here is a central angle. The sum of central angles measures, the sum of the measures of the central angles of a circle with no interior points in common is 360 degrees. So if we just kept drawing more and more angles, right? If I had this angle, and then I can make a really big one. Let's try and do it in purple. Like there, 1, 2, 3. And then I have this guy over here, 1, 2, 3, 4. If I add up all 4 of these central angles, they're gonna add up to 360, right? Just like a full circle. So a central angle is just an angle whose vertex is the center of the circle. And when you add up all central angles, they add up to 360 degrees, a full circle. Okay, so based off of that, we're gonna start talking about arcs. An arc, what's an arc? All right, so I wanna put a dot for the center of my circle in each of these. All right, so an arc is basically the portion of the circle that's kind of, sectioned off whenever you create a central angle. So for example, if I have this guy right here, right? Here's my central angle. So I've separated my circle into this little section within my central angle area here and everything else, right? So I'm gonna highlight that because, you know, I'm visual and I have to do that. This guy right here. We call that a minor arc. Any portion of our circle that's kind of sectioned off when we have a central angle, that's called an arc. So this little rounded section right here is called an arc. It's part of our circle that we get when it's like a slice of pizza, it's the crust, right? That's an arc. So if it's less than half the circle, if it's less than 180 degrees, it's a minor arc. So this is a minor arc. Okay, then if we draw the exact same thing, I'm gonna try and draw the exact same thing. Same arc, right? Now we're gonna focus on the other portion of the circle, right? This whole thing that's left over. So not the portion inside my little central angle here. Now we're talking about this whole central angle, which is huge, right? So that's big time, way over half a circle. So we call this a major arc. And then what happens if it's exactly half the circle? It's not less than half the circle. It's not more than half the circle. What happens if it's exactly half of our circle? Let's see how good I can draw a straight line here. There we go, good enough. Okay, so if we talk about either one of these halves, it doesn't matter which one. Let's say I talk about this part. And it's the portion of the circle that's sectioned off from this 180 degree interior angle, right? It's 180 degrees, exactly half the circle. So then this portion of our outside circle is also exactly half the circle. This is a semicircle. Semicircle. Okay, so again, think about like a pizza, slice of pizza. The arc is the crust. So if you're taking a slice of pizza away from the rest of the entire pizza, like this guy, the little portion of crust here, that's just a minor arc, right? It's not half the circle, it's just a little piece of the circle. The rest of the pizza that you're leaving, say you take this piece away, the rest of the pizza left, this is a major arc because this is way more than half the pizza left, right? So this crust would be a major arc, this portion of the circle. And then if you happen to take exactly half the pizza, right? If it's cut into 6 slices and you eat 3 slices, so you've taken half the pizza, the amount of crust you've eaten, or you could say the amount of crust you have left that you haven't eaten yet, is exactly half. So this portion of the crust is a semicircle. It's not a major arc, it's not a minor arc, it's exactly half, so it's a semicircle. I hope that's making sense to you guys. All right, so classify arcs and find arc measures. WC is a radius of circle C. Remember how we name a circle, has a circle with a dot in it and the center point. So here's our drawing that we're looking at here. WC is the radius. So we want to kind of focus on the fact that this is the radius. What else is the radius? Well, XC would be the radius, right? And YC would also be the radius, and XY goes all the way across through the middle, so that would be the diameter. We don't have to focus on that. All right, identify each arc as a major arc, a minor arc, or a semicircle. So the first one we want to look at here, and this is showing you how to name an arc, okay? You only need 2 letters to name an arc unless there's a lot of central angles and you need more than 2 letters to be specific. All right, so for the measure of arc, X, Z, Y, how do I know what portion that is, right? Well, here's X, here's Z, and here's Y. So I'm talking about this arc. If I would have just said arc XY, I don't know if I'm talking about this side or this side, right? So we use one of the points on the side we're talking about, X, Z, Y, this arc. I don't want to mark it because there's other questions on it. But if we're talking about this arc, that looks like it's exactly half the circle because it's in between this point and this point, and they create a 180-degree central angle, right? So this guy, the crust left over of the pizza, is exactly half the circle. So this is a semicircle arc. My dog just sat on a baby toy. All right, B. Arc, the measure of arc, WZ, oh sorry, if it's a semicircle, the measure of the arc is 180 degrees. I don't know if it'll get to this yet, but I'll just go ahead and tell you that the measure of an arc matches the measure of the central angle that it's a part of, right? So up here, if I would have said that this central angle right here was 30 degrees, that means the measure of this arc is 30 degrees as well. The measure of the arc is 30. Now, we're going to start talking about how to measure the length of an arc, but the measure in degrees of the arc is the same as the measure of the central angle it comes from. So when I'm saying from X to Z to Y, this is a semicircle because it comes from this central angle, and that's 180 degrees, this angle right here. Then that means the measure of this arc is 180 degrees. Okay, next one, measure of WZX. Here's W, here's Z, and here's X. You have to go through the letters in that order. So you start on point W, pass through point Z, and end on point X. Start on point W, pass through point Z, and end at point X. We can't mix up the order and say WXZ. It's asking us for the measure of WZX, so that's this whole arc, right? Well, we already know that this portion is 180. This right here is 90, which means this is 90 as well. So from here all the way around, that's 90 plus 180, right? Which is 270. So this whole arc is way bigger than half a circle. It's actually 270 degrees. So that's a major arc. When it's over 180, it's a major arc. And it is 90 plus 180, 270 degrees. Okay, and then lastly, we have the measure of arc XW. So X to W. There's no other letters in between, so we don't need to pass through Z or Y. we're just going straight from X to W. So we're just talking about this guy. This portion of our circle, the crust, comes from this slice right here. This central angle is 90, so it means the measure of this arc is 90. Since that's less than half a circle, this is a minor arc, and it's 90 degrees. Okay, just classifying. So your arcs are gonna be one of three things. They're either gonna be exactly half a circle, 180 degrees, so they're a semicircle. They're gonna be less than half the circle, so they're gonna be less than 180 degrees. It could be 179 degrees, that's okay, and it would be a minor arc. Or it can be more than half a circle, so 181 degrees or more, and that's a major arc. All right, one more page for this video. The sum of central angles. So here, fill in the blanks, the sum of the measures of the central angle of a circle with no interior points in common is 360 degrees, which we have already said. So for example, here in this little picture, we've got this guy, and this guy. So if I add up angle 1, angle 2, and angle 3, I'll get 360 degrees. Okay, there's no other points separating these angles out. Together they all make up a complete circle. So angle 1, oh, I should put the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 all add up to 360 degrees, like we've already said. So based on that, let's do a few practice problems. Show how to find the value of X. The measure of angle QTR is 40 degrees. So here's our picture. I'll zoom in. QTR, this, here, I'll highlight it. This angle right here is 40 degrees. So how can I find X? Well, we just said that all the interior angles, as long as there's nothing else left over, right? It's not like I'm saying all of this except for this angle or except for the yellow angle. What do these all add up to? I don't know what those add up to, but I know all of them add up to 360. So I'm gonna add them all together and set it equal to 360 to solve for X. So 40 plus 8x minus 4 plus 13x minus 3 plus the next one, 5x plus 5. I'm trying to color separate it so you can see, sorry. 5x plus 5 plus, and the last one is 20x. And I know together those all add up to 360 degrees. Okay, so I'm gonna combine like terms and solve for X. I'm gonna start off by combining all my numbers that don't have an X with them. So 40 minus 4 is 36, minus 3 is 33, plus 5 is 38, so 38, plus, now I'm gonna add up all my X's. 8x plus 13x is 21x. 21, I think, right? 23, 20, yeah, 21x plus 5x is 26x plus 20x is 46x. And that all adds up to 360. I'm going to subtract 38 from both sides to try and get x by itself. These go away. 46x equals 322, and then I need to divide both sides by 46. 322 divided by 46, my handy dandy calculator, my 7-year-old had it playing on it last night. 322 divided by 46, 7. X equals 7. I like when numbers turn out to be nice, clean, whole numbers. Okay, so all it said was to solve for X. We did. X equals 7. Let's do it here. We've got 145 degrees, 165 degrees, and X, right? So 145 plus 165 plus X, and we know they all add up to a full circle, which is 360. So 145 and 165 is going to be 310. And then minus 310 from both sides. X equals 50. You don't have to put the degree symbol because it's already got the degree symbol at X. So you're just putting a 50 in for X. But that whole angle is 50 degrees. Okay, and then number 2, 40, 85X, and this guy is a 90-degree angle. They're all going to add up to 360. So 40 plus 85 plus X plus 90 equals 360. 40 and 85 is 125, plus 90 is 215. And then minus 215. X equals 145. So this angle is 145 degrees. Again, you don't have to put the degree sign because it's already there. But this whole angle is a 145-degree angle. All right, let me know if you have questions, and make sure you stay tuned for part 2 of this lesson.